Welcome back. We want to still continue solving problems on kinematics, example 2. This one says the motion of a particle along a straight line is described by the distance function x equals to t cubed minus 9t squared plus 27t minus 10. Find A, the velocity and acceleration after 2 seconds, and B, the distance when the particle is momentarily at rest. Okay, so the distance function is x equals to t squared t cubed minus 9t squared plus 27t minus 10. The first instruction is we should find the velocity, and secondly the acceleration after 2 seconds. Okay, so before we continue, we had discussed this in our previous class, the first example, that the first derivative of a function of a particle represents the velocity, and then the second derivative represents the acceleration. So if you have not watched that video, please I would advise you go back and just try to go through that very video, because it will help you to understand some things about this one. Okay. Assuming we have the particle to be x equals to this. Okay, so for us to get the velocity means we have to find the derivative of this function. The first derivative will be the x over the t. So the x over the t, that will give us 3t to the power 2. 3t, we didn't get that perfectly. Okay, so here would be 9 times 2. 9 times 2. Then the 2 here reduces to 1. This 27t, the derivative of this one will give us 27, and the derivative of this as a constant will give us 0. So I eliminate that. So the x over the t, which represents velocity, is equal to what we have here. Now, we were asked to find velocity and acceleration, but let me start with velocity first. Velocity after 2 seconds. So the t here represents time. I'm going to substitute 2 in place of t, just as we did in our first lectures. In place of t here 2, I'm going to put, alright, 2 squared gives us 4. So this expression will now reduce to 4. And then 4 times 3 will give us 12. Done with that one. This is 2 times 2, which is 4. 4 times 9, this gives us 36. Anyhow, you're going to multiply all of them, you get 36. And here we have plus 27. When you simplify this, it gives you 3 meters per second. 3 meters per second. So we've been able to solve for the velocity. Been able to solve for the velocity. And then we are not done yet because we were also asked to find acceleration. We still use that function for the particle. The second derivative of the function will give us acceleration. The first gave us velocity. The second will give us acceleration. So the square t, the square x over dt square. So the acceleration is the second derivative of that function, and it will give us 60, or it gives us 60 minus 18. What is the t? It was given in the equation, which is 2 seconds. So I'm going to replace 2 in place of t. 6 times 2, this is 12. Then 12 minus 18 gives us minus 6. So we have minus 6 meters per second square. Meters per second square. So I can now proceed. Then the second one says B, the distance when the particle is momentarily at rest. The distance when the particle is at rest. If the particle is at rest, it therefore means that the velocity is 0. So we start this way. B, the x over the t equals to 0. This expression reduces to 0, and if you look at it critically, you see a quadratic expression, and this is divisible by 3. So looking at this carefully, this expression can still be reduced. This can still be reduced. So if I divide this by 3, then this one is out. Dividing 3 by 3, here what do we get? So we have t squared minus 6t plus 9, dividing all through by 3. And if we factorize this expression, we will have that t is equals to plus 3. So we simply say t, let me zoom this so that You can see it clearly. Of course, I believe that you still remember how to factorize. We have the sum and difference here to be minus 6 and product here to be 9. Okay, so if you simplify that, then we will have t minus 3 minus 3 the same thing times 2 equals to 0. Which, if we should solve for t, then we will have that t is equals to plus 3. And 3 stands for or represents time. But the question said we should find the distance when the particle is at rest. So by initiating v is equal to 0, it gives us the time. We are now going to substitute the time into the value or the function for the particle, which is the x here. So let me take this down. Alright, so we now substitute the value of t is equal to 3 here, 3 here, so 27 times 3, and then we simplify. When we do that, we will get our final answer to be 17 meters. So that's far I can go for today's class, and I believe you enjoyed our lectures. And if you did, please, I want you to share our videos, recommend it to others. Also try to subscribe, like and share. Have a wonderful day. See you in our next class. Bye.